Review Day 4, we're looking at domain and range, and we have talked about it in passing a few times, so I think this will sit well with you and not be difficult. First of all, we talked to you about what the definition of a function is. It is a rule that gives a single output number for every valid input number. Domain we gave you as a definition. Come on. The valid input numbers, or your X values, are your domain. The word valid is important as well. Input, we don't often think that way, but the independent variable is X. It is your input into the function to give you an answer. Your range would be the answers. Set of output numbers is the range of the function. That tends to be our Y values. These are the dependent variables. And it is our output, or our answer. Let's look at a few specific functions and look at the domain and range. Okay. For the first one, we have a line. If you notice, your line goes up to the right, down to the left, forever and ever. So it is going to the right and will continue to go to the right for infinity. It will continue to go to the left to infinity as well. That means there is any possible value of X is valid. The domain equals, and we tend to write it as curly bracket, X can be any real number. The little e actually means is an element of the set of real numbers. But that definition works fairly well. You can also see that that line will go forever upwards. Now it's going upwards at a slant, but it's still going to go upwards forever and downwards forever. That means that the range can be anything. This is a different looking R. The range can be any Y value too. That means eventually you will get a Y value of 10,314,000,000. Any value is valid for that line that goes continuously forever. The next function doesn't have a lot of X values and Y values. Notice that it is a function because I can draw any vertical line and it will only ever hit that in one place or less, not more. So it is a valid function. My X values are very specific. My domain has only 1, 2, 3, 4, 5 possibilities. According to my eyes, the X values can be -3, -1, 1, 2, and 3. The Y values are also specific. There's one less of those. 4 from that first left one, 2, 0 twice, and -2. But because I can put a vertical line and only hit once, it is a function. The third one is a parabola, which we know, and we did look that a parabola is a function. And since X can be any real number, this function goes forever to the right, slowly, but it will go forever to the right and to the left. The domain is X can be any real number. The range. Notice that there is a restriction on the range. There are no negative values for Y. There is no function down here. So there is a restriction that Y has to be greater than or equal to 0. I put a straight line. Some books put a comma. And Y is any other real number as long as it's greater than 0. When you say real numbers, you're saying it's not a natural number, not just 1, 2, 3, 4, 5. Y could be 1.76, 2.13. It's all the little bits in between, but it has to be greater than or equal to 0. To just reiterate that in English again, that means set. So what we are saying by that notation very succinctly is that we have the set of y such that y is greater than or equal to 0, and y is an element, or any y is an element of the real numbers. All that in cute little curly brackets. Up above, this also means the set, but it means our domain. We have x that can only be part of this set, a very finite set. Y has to be part of this set as well. So we are saying the range is the set of the second elements. For the ordered pairs that make up that function. It's often easiest to state domain and range when you have a graph in front of you, but we should be able to do it looking at either a set or an equation of a function. The first one is a set of 5 ordered pairs with a boo-boo on it. Our domain is always the first elements. So it is the set of the first elements, which are -2, -3, -4, already had -3, and -1. Notice that this is not a function. It is a relation because there are 2 possible values for x equals -3. You can still have a domain and range of relations. The range is the set of second elements, which would be 2, 3, 4, 5, and 6. For B, we have a parabola. We know what our parent functions look like. We can also cheat from the cheat sheets at the front of the room. We know that it looks like that. But you can also state for any parabola that is centered at the origin, because we haven't moved that parabola anywhere. It goes through 0, 0. You can take it to the bank that the domain is all possible real numbers for the domain. Y has a restriction greater than or equal to the vertex. If it's an upside down parabola, we would do less than or equal to the value at the vertex, but we have a range for that particular parabola. We also know a lot about lines, and we can take that to the bank as well. When you have the equation of a line, you know that the domain will be all possible real numbers. You know that the range will also be all possible real numbers unless this is a vertical or horizontal line, then we have specifics. But for a general line, this one has a slope of -2 up 3. We have a line like that. You know the domain and the range could be all possible real numbers. I'd just like to talk through 2 word problems talking about domain and range as well. The height of a ball is modeled by the equation h equals -5t squared plus 10t plus 15. I apologize, I made a mistake on that diagram and I caught it as I was reading it to you. The height is minus 5t squared plus 10t plus 15. We are going to spend more time later looking at quadratics, but we do know a fair bit about them. That number represents something important. That number represents something important, and so does that. If you have a ball being kicked into the air or hit or whatever, you have the force of gravity working against you, which is about minus 5. You have an initial velocity, which is about 10. And you have an initial height, which is about 15. So the initial height of our ball is at about 15. It travels upward for a minute, well, a second really, and then that ball travels downwards from the force of gravity. So it would make an arc like this parabola. We have been asked, what is the domain of the function? It doesn't make sense to have a time, which is our domain, the independent variable, time as a negative number. So this section of our graph doesn't really make sense as far as the ball goes. I should have started my graph right here and showed its path from when it was initially hit, its highest point, and back down. It also wouldn't make sense to have the parabola go any further down here, because that means it's gone through and under the ground, which is silly. So the domain of this particular function, we're using t, we would say that t has to be greater than or equal to 0, initial time. We also notice that once it hits 3 seconds, that ball should be stopped, or at least onto another bounce, because it won't go through the ground. So time would also be restricted in that sense. But you can have parts of seconds, 1.3 seconds, 1.75 seconds. So we can say that t otherwise would be all the little bits in there. It is a real number between 0 and 3. The range of the function is the dependent, which is your height. It doesn't make sense to have your height below 0. That would be in under the ground. So height also would be greater than or equal to 0. It hits a maximum height of 20. You have to trust your eyes on that one. But it can be all the little bits in between. It is a real number lying between 0 and 20. Farmer Zach has 100 meters of fencing and he wants to enclose a rectangular pansy garden. Express the area of the garden as a function of its width. What is the domain and range of the function? So my goal is to come up with a function for area in terms of a function of its width. So I would like a function that looks like that has w's. I'm going to call the width w. It means there's another w over there. If I have 100 meters of fencing, I have 50 of it that can go along the top and along the width. So that would be 50 of it. The other two sides would also give me 50 meters of fencing. So my length is going to be 50 minus w, whatever I took up over here. So if I had a width of 10, I would have a length of 40 to use up 100 meters of fencing. Area is length times width, so it would be w times 50 minus w. I'm going to tidy that up a little bit. Using the distributive law, I get 50w minus w squared. I know that I have a quadratic, which would be graphed like a parabola. So I should have a domain that follows a parabola. But we have a real-life problem. So I know I can't have infinite width. I can't have infinite area. I need to think about practical numbers for this problem. The domain and range can seem kind of silly when we put restrictions on width and area. But first of all, I'm going to look at one silly scenario. is where I have 0 width. So I take my fence, I run it 50 meters, and I turn it right around without any space between and run her 50 meters back. I can't put any cows in that area, but I have used up all my fence. So my width has to be really greater than 0, but it certainly can't be negative. The largest number my width could be is if I run it the other way. And I have a width of 50. So I run it this way 50, turn around, back up 50. My width is 50. So my width has to lie between 0 and 50 for those two silly scenarios. Looking at the equation, if I put a 0 in here, I have an area of 0. Not helpful in the least. What is the maximum area that I can have? Well, the maximum area is certainly not when W is 50, because if I put a 50 here and here, I get a 0 area as well. So the maximum area that I can get is right in the middle, is when your width is 25. I am getting that knowledge from grade 9 when we looked at the fact that a cube makes the most maximum area for a given perimeter. So my maximum area is 625 meters squared. Now that knowledge wasn't the important part of this exercise. It was looking at the domain and the range when we have a real word problem. So the domain of this problem is 0 less than or equal to W less than or equal to 50, where W is a real number. And the range is 0 less than or equal to area less than or equal to 625, where area is a real number. For homework, please try course notes 20, 2, 3, 7 to 11, and page 35, even more importantly, 2 to 4, 9 to 12, and 16.